Good morning. As the week progresses, it's more and more difficult to get here on time, but it's very nice to have a full audience today. It's my great honor to introduce Doug Butterworth, Professor of Applied Mathematics at the University of Cape Town, to deliver today's keynote lecture. Doug Butterworth needs no introduction, really, but just to get the show moving. He was trained in fundamental particle physics, but soon moved on to specialize in mathematical modeling approaches to the assessment and management of renewable resources. His management procedure approach has provided a structured basis to take proper account of uncertainties in fisheries management, and he has applied it to advise on appropriate levels of catch for most of South Africa's major resources, fisheries resources, and internationally for whales and the IWC, Antarctic krill and at Kamala, and tuna, both ICAT and CCSBT. He's also been involved with FAO in consultations on CITES and eco-labeling, and has been invited to provide advice on fisheries matters by government departments in 12 countries and by fishing industry associations in 10 of them. Doug is one of the most influential resource scientists in the world, tackling many controversial management issues in a systematic, robust, uncompromising and evidence-driven approach. I speak with personal experience on this. Even those who hold opposing views, and you will acknowledge that anyone dealing with whales and krill management will have to experience opposing views, treat the results of his investigations with great respect. This is a science conference, and Doug has also an impressive research output supporting his views, with almost 200 research papers and some 5 times this number in technical reports. He has trained many students and practitioners who are now leaders in the field in their own right in Europe, the US, Australia, Africa, and some of them are in the room. Professor Butterworth was recently awarded as well the Order of Mapungubwe, which is the South Africa's highest award offered by the South African President for his scientific contributions to fisheries management. Please welcome Doug Butterworth.
Thanks, Manuel and ICES, for this invitation, and thank you all for getting up at this unholy hour of the morning. What do you want from a keynote speaker? It occurs to me that you want something interesting, informative, entertaining, and controversial. So what do organizers of these conferences normally do? Well, they invite Ray Hilborn. Well, sorry, folks, he wasn't available, so you've got me instead. And apologies again, I won't be saying anything about MPAs or updating Ray's orangutan conversion factor. And in case some of you weren't at the World Fisheries Congress in Edinburgh last year, the orangutan conversion factor, I'll inform you, is the number of orangutans you lose to deforestation to clear more land, to grow more crops that you need to replace the sustainable yield that you lose per unit area of MPA creation. But even if you haven't got Ray here, nevertheless, if you don't disagree with at least something I have to say this morning, well then shame on you, because you must be about to go to sleep. Okay, an outline of what I'm going to say. I'm first going to be discussing 2 essentially different methods of giving fisheries advice, what I call the best assessment-based management, and then management procedure basis for providing that advice. I'll talk about TACs, but really you can generalize that to any management regulation. A key point that comes out of that is how precautionary is precautionary, if I put it that way, and the problems of consistency in scientific views around the world. I'll then go on to talk about scientists a little bit, the key problems they face and their appropriate role in the advice-giving process, and finally end by looking ahead in, I hope, somewhat provocative fashion. So let's talk first about best assessment-based management, and a primary example here is the US Magnuson-Stevens Act with its MSY-related recovery targets, which has codified the practice to a large extent. Effectively, I think we all know what we mean by the best assessment of a resource. You combine that in some way with a catch control law, and out of that comes a TAC. Now, there are a number of difficulties associated with this approach. Perhaps the most serious is that assessments change from year to year, particularly if you have them from year to year. Not only do you get more data that change the results, but scientists can't keep still and keep thinking they improve their methods, and they have difficulty in estimating what MSY reference points are. So the TAC advice can jump around all over the place, which is not very good for industrial planning. Importantly also, you can't really, with that approach, sensibly approach longer-term trade-offs between risk to the resource and the reward you're going to get in terms of the catch. The key reason for this is the most you can do with best assessment-based work is take things like constant catch projections, and they don't factor in the important point that as time proceeds, you will gain more information. So if things are going wrong, you'd find out from your monitoring information and you'd correct your constant catch. So that's another major problem. I'm not going to go into every one of these. We all know about the lengthy haggling that's involved every year. What's particularly important is what happens if your best assessment this year turns out to be wrong? Exactly how do you take that into account? And again, I'm going to leave that last point for the moment. Now, let's have a look at USA fisheries and the following information courtesy of Rick Methot. I hope I haven't manipulated it inappropriately, but there are about 450 stocks under management plans. Of those, about 55% are model assessed. I was a bit surprised about this next answer. The direct estimates of MSY or FMSY for about 40% of these, or about 22% of that total number of 450. And the most common proxy for MSY for the rest of them is F spawners per recruit, expressed as a percentage. You're used to hearing the F30% or F40%. But even given this, I think 40%, 22%, whichever way you want to state it, is perhaps on the high side if you're looking from a reliability point of view. And in essence, MSY-related targets are generally not well determined, and that's one of the problems. Now, this is not a new problem. If I take you back 40 years, perhaps the first international attempt along these ways to better codify management practices for fisheries was the International Whaling Commission's new management procedure, which was put together in 1976. Now, the details of that don't matter so much here, except, let me say, the blue curve is the sustainable yield curve. The red line is the catch control law. But what's important to implement that red line, to use it to calculate a catch limit, you have to know three things. You have to know what your current abundance is, what your pristine abundance is before exploitation started, and you need to know what MSY is. Now remember, this was 1976. Within 10 years, it was acknowledged that the NMP had failed. And why had the NMP failed? Not because the concept was wrong, but because of problems in calculating the things that you needed to be able to use that red catch control rule. Not only calculating them, but also how to take uncertainties in that calculation into account. And I think it comes down to very much what my statistics colleague Walter Zucchini says, and his advice is don't parameterize the world if you can't estimate the parameters. In other words, concepts alone are not enough. You have to be able to estimate their values if you're going to be able to operationalize, to use that wonderful American word, your approach to management. So essentially in the IWC in the mid-80s, the solution found to this problem is what came to be known as the management procedure approach, which I'll go into in just a moment. So just to summarize again, the key difficulties for the IWC's new management procedure were two. First of all, how to work out from that best assessment, well, how to get that best assessment and how to work out your TAC from it, bearing in mind the problems of estimating something like MSY. And secondly, the question of, you weren't certain about this. What happens if you were wrong? What security did you have? And I tend to say, ditto repito the US Magnuson-Stevens Act, and I'm not getting at the US particularly because this is pretty much a general phenomenon you'll find around the world where best assessment-based management is approached. And I asked the question, why has the IWC lesson apparently still not been learned some 3, even approaching now 4 decades later? But why is fisheries management so difficult? After all, the concept of sustainable utilization is easy. You can take it by analogy. There are plenty of economists here, so they'll like this. You just use money, and everyone understands money. If you're a pensioner, you've got to live off your interest, not delve into your capital. What do you do about that? You go to the bank. You ask the teller, how much money in my account? You ask him, what's the interest rate? You multiply the two together, and bingo, just make sure you don't spend more than that, and you can live happily ever after. So the whole exercise is easy. But why is it difficult when we come to fisheries? Well, the way you can explain this is our problem is we have uncooperative bank tellers. First of all, they won't tell you what the interest rate is, and in any case, it's not static. It fluctuates considerably, even goes negative at times. And what I'm talking about there, of course, is recruitment fluctuations. Secondly, when you ask them the balance, they won't tell you that either. Well, they will tell you something, but they'll only tell you once a year. There'll typically be an error of about 50% on it, and they'll tell you the opposite currency. You want dollars, they'll tell you rubles. And what I'm talking about here is we have surveys annually. We know they have large errors, and they have unknown biases as well. So that's our problem. Now, what are management procedures all about, or management strategy evaluation, as it's sometimes called? What new do they bring to the table that helps us solve these problems? And essentially what they bring to the table is feedback control. And what that means is you monitor stock changes and adjust your management measures, such as TACs, accordingly. So let's again go to a financial analogy to make the point clear. Let's say we had $1 million invested at 5% per annum. Each year we withdraw $50,000 to live on. I should inflate these figures, by the way, but anyway. At any rate, your investment is sustainably maintained at $1 million. That's sustainable utilization of your resources. If you want to put it in fisheries terms, we have a 1 million-ton fish stock. It grows naturally at 5% per annum. Each year you take out 50,000 tons, and we have sustainable exploitation. The resource is kept at 1 million tons. But now let's imagine something that doesn't necessarily have occurred. It may have occurred. We're not certain. Someone may have stolen $300,000 from your investment, and you keep on withdrawing $50,000 a year. Well, you may go and sue the bank as well, but that's another factor. You know how long it takes for legal action to be of effect. So two things can happen. Remember, you don't know which it is. The blue line there is up to the present moment. The purple line, what happens thereafter. You're carrying on taking out $50,000 a year. If this theft hasn't occurred, everything's happy. On the other hand, if the theft has occurred, after about 20 years, you don't realize that you've got only about 5 years to go before you're derelict. So, same analogy with fishing. It may be recruitment failure, it may be IUU fishing, you're not certain, so it may have occurred, you don't know it has occurred, but you carry on taking 50,000 tons a year, and that's what's going to happen if you do so. The resource, if it occurred, if the theft occurred, remember you don't know, the resource is going to be rapidly reduced. So, why is there any problem with this? If this was just money, you'd go to the bank teller, you'd ask, well, the balance, he'd tell you there's 700,000, you'd throw a fit. But the problem is the fisheries teller will only give you advice which is accurate to about 50%, and we'll forget about the problem with the conversion rate as well. So let's see what is going to happen here when all we're getting is annual abundance surveys which give us information with this sort of quality. So now you can do some work again. Contest for you. You've got to tell me in the two examples I'm going to show you in which case $300,000 has been lost from your account. Okay? So have a look left and right. I'm not telling you whether it's the one on top or the one below. You're all fisheries managers, so you're supposed to get this right. That's the information you've had from the teller for the last 5 years. Now comes this instance, you think there has been a theft from your account, and this is the information you get from the teller for the next 5 years. Now, I'm not telling you yet which of these, one of the two cases, the money's been withdrawn from your account without your knowledge. Okay, that's after 5 years. That's after another 5 years, 10 years. That's after 15 years. Have you made your minds up yet? Is it the top one or the bottom one? Well, that's after 20 years. If you said the bottom one, you got it right. Okay, well, let's try it again if you were struggling with the concept. Here again, that's what he's been telling you the last 5 years, but you know everything's been okay. Now the theft may have occurred. 5 years information of this super high quality we get in fishery surveys, 10 years of that information, 15 years of that information. You made up your minds yet? 20 years. Well, if you selected the top one there, you got it right. Don't worry, no examination here. I won't ask you got 3 out of 3 at the end of this. Okay, third one, just to get the idea, 5 years. Now the first 5 years after the possible theft, the second 5 years after the possible theft, the third 5 years after the possible theft. Well, you thought it was the top one was okay, but look how fast that's coming down. After 20 years, well, actually you were right if you said the top one was the one that was okay. So what are the impressions you get out of that? Remember, this is typical of the situation we have in fisheries management. First, that it wasn't easy to tell which of the two was the case where the theft had occurred. Secondly, it usually needed about 20 years worth of the sort of data we're getting to be sure which of the two cases exhibited this effect. And third, by the time you knew which it was effectively already too late. If the theft had occurred, you'd almost exhausted your account if you'd done nothing about that possibility. So, same sort of thing about fisheries. If you just carry on regardless, you can easily get yourself into trouble unless you're careful because of the nature of the data we get. Now, how can we deal with that? Let me contrast 3 strategies. Another name for them would be management procedures. The first one is what we've been doing at the moment. Just take out that $500,000 a year from your account irrespective. The second one is, well, we'll listen to what the teller says. It's highly variable, but we'll take 5% of that each year. We happen to know in this case that the interest rate is 5%. And the third one will do something a little bit more complicated. Whatever we took out last year, we'll take 80% of that, and we'll add to that 1% of what the teller tells us. So in other words, we're trying to smooth things out a little bit there. And the whole point about my strategy or my management procedure is it's got to work whatever the real situation is, whether or not the theft occurred, because we don't know. We're operating in a climate of uncertainty. So let's have a look at one simulation here. The 3 strategies going down in the rows there. On the left, no theft. On the right, a theft. And you see what happens in the first case as far as the withdrawal is concerned. It's the same. In the second case, what you withdraw bounces around enormously. You can have years of plenty when you take a large amount out, but you also have to go to put up with years of not very much to live on. In the third strategy, you can see at the bottom, we do manage to smooth things out a little bit. Now, what about the resource? That was the withdrawal. In that case, what's left in my account? On the left, no theft. On the right, theft. The first case is hopeless, because if the theft occurred, I'm in shtuk. The other 2 cases are basically okay from the resource point of view. They keep it about where it was. If there wasn't a theft, they go down to keep the lower amount stable if there was a theft. Now, that was just one scenario. Here's what I get if I look at a number of simulations here. As far as the catch is concerned, highly variable for second strategy, smoothed out a bit in the third strategy. As far as the resource is concerned, first one again hopeless, other 2 not unrealistic. Or not unreasonable. If there wasn't a theft, we keep our balance about the same. If there was a theft, we restabilize around where we were after the theft occurred. So what can we say in terms of performance? Under strategy 1, hopeless, we were going bankrupt if the theft occurred. Second one was fine as far as my bank balance was concerned. It stabilized if there had been a theft, it stabilized the capital at where it was after the theft, despite what we took out. But its problem was the catch, or what I took out of the account, bounced all over the place. Number 3 was certainly the best of them. It got me reasonably stable withdrawals at the same time as safeguarding the resource where if there had been a theft. So at the end of all this, what can we say? Formula 3 is automatically correcting for the effect of, in fishing terms, a recruitment failure or IUU fishing. And that's what I mean by feedback control, by taking the teller's information, even though it wasn't very good, we're able to adjust in a reasonable manner. So this is essentially what the management procedure approach does, or management strategy evaluations. The first thing you've got to do is specify alternative plausible models of the resource, because there's never only one model with fisheries. There are typically plenty of models that could describe the information that you have available. Call those operating models. The second thing is you're not completely unconstrained with those models. You do have to make sure those models are consistent with what data you do have. The third thing you do is you agree your objectives for fisheries management and you translate those into performance indices, performance measures, and then you go into the computation, you simulation test alternative strategies or management procedures, and you look, as we did in that financial example, you look for the one that gives you the best trade-off between your various objectives, which in the financial analogy were making sure you didn't exhaust your capital, but also keeping a reasonable amount withdrawn and keeping that amount reasonably stable. Okay, so our management procedures, the way of making the difficult, which is assessment-based management, easy. Well, let's ask that question by trying it out for some simple procedures applied to some North Atlantic stocks, and we're going to pretend we're going back 20 years in time to 1990, and based in what we knew in 1990, I'm going to set up some management procedures for a couple of North Atlantic stocks and see how well they'd have worked. Some very simple procedures. Remember, these are stocks that not entirely, but effectively were managed on the basis of advice coming from complex annual assessments. And what I'm doing here is reporting on work one of my PhD students has been doing over the last couple of years. So the importance of these simple management procedures is they're going to be applied using only one index of abundance. Okay? And I'm going to look at three of them. I'm going to show you constant catch, but that's really just a benchmarking, not to be taken seriously, but two to be taken seriously. First of all, one based on slope, and that's just looking at your recent trend in the abundance index. If it's going up, push the TAC up. If it's going down, push it down. The other is a target-based approach, which says we've got a target we'd like for this index. If we're below it, we reduce the catch. If we're above it, we increase the catch, and the further above or below, the greater the extent to which we change the catch. Both of those will essentially stabilize you at some level eventually, and they're both of a feedback nature, as you might have noted. Well, if you like formulae, those are the formulae, but let me not dwell on that as long as you've got the general idea. Now, the first example is North Sea sole, and for that, the index of abundance as it was in 1990 and as it continued to be are as shown here. The data that's been used up to 1990, we've used not only those data, but the other data that were available for management, the age structure, and so forth. But remember, this procedure after 1990 is going to set catch limits based only on that index of abundance, nothing more, no complex assessments. Okay? And that's the sort of picture we have when we do the assessments. Remember, we've got to make, or the projections, we've got to allow for the fact that we don't know things like future fishing selectivity. We don't know things like how much recruitment, whether it's going to, the variations, are they going to be up or down? And any one of those so-called worms could occur. On the left, the spawning biomass. On the right, the annual catch. Now, you don't want things going very low. Effectively, what we've tuned that management procedure to do is, and this is purely to make the comparisons easy, we've made them, we've selected the parameters of the law such that at the lower 2.5 percentile, we get the same spawning biomass as occurred in practice after the complex assessment-based TACs. So it's tuned to give you that. You're taking quite a cautious approach to make sure you don't knock the resource down too low. Now, that's what could have occurred in 1990. What did occur is what's shown there. The black triangles because now, 20 years later, we know what the recruitment fluctuations were. The black triangles on the left is what spawning biomass turned out to be under the advice that was given and manipulated, no doubt, but whatever. The two blue and green curves come from the management procedure, the red curve from the constant catch, and on the right you see what happened to the catches. Now, it's a bit difficult to see the comparison that way. Let's do it another way. In these plots, what the black line is, it's contrasting the three management procedures. The black line is what happened in reality. For instance, the top left plot is the average annual catch. The green and the blue points are those what those simple management procedures produced, and you'll see they've gave you virtually the same average annual catch. Importantly, on the top right, what that's showing is how much did the catches vary from one year to the next. And there you see, compared to 15% on average in actuality, only somewhere between 7 to 10%. Bottom left, where did you end up with? Well, black lines where you ended up with. These end up with the stock quite a bit better, almost double. And finally, how low did you go? Because you don't want to go very low. Well, same story again. You didn't end up very low, certainly not as low as the normal advice took you. Now, maybe that was too easy a test. Let's try another one. And let's go to the other side of the Atlantic, New England, and anyone who's been in New England knows the main problem with assessments there is retrospective patterns. Here's witch flounder from the Gulf of Maine, and that's the retrospective pattern in the assessments. Well, how well does applying this approach to the witch flounder situation do? Same summary presentation of results, and you can see there, top right, virtually the same catch. Top left, 5% variation in catch per year compared to 15% in actuality. Bottom left, where did you end up with? Well, virtually in the same place. Bottom right, how low did you go? Well, you didn't go as low as the resource was taken in reality. So, what are conclusions from this? The management procedures did as well, possibly even better in some cases, than what occurred in practice, using complex assessments. Admittedly, not exactly, but effectively the actual advice was based on them. So you ask the question, how important are those annual assessment-based management or assessment results and basing management on them? Are you following noise more than signal? And this is not saying throw complex assessments away. What it's saying is there's a different role for them. They provide the so-called operating models, the basis on which you perform these simulations to come up with the simple rules that you use on a regular basis to set the catches. You don't use the assessments themselves to set the catches. This can save you enormously on resources once you come to apply them. You don't have to put all that effort into doing the complex annual assessments every year. And even in circumstances where there are problems with the assessments, for instance, in that witch flounder case, they seem to be able to manage it reasonably. And these aren't the only two cases we've looked at, though I'm not pretending that this is anything more than an initial investigation. So essentially, we've solved the problem, use management procedures, and it's all in easy. Now, like everything, the answer is regrettably no. And why is it regrettably no? The point is that management procedures, remember, are intended to work not just for your best appraisal of the resource, your best assessment, but for other possible plausible assessments of the resource. You're never certain, so the whole point about management procedures is they must be robust to those uncertainties, but even though feedback does a lot for you, it can't do everything. It's very easy to dream up scenarios, and usually even ones that are consistent with the data you have, where your management procedure will fall over. Now, the question is dream up versus what's plausible. And that's the key issue now. How do we limit plausibility? Or in other words, how precautionary do we need to be? And the key question, which confounds some of the groups that are trying to use this approach, is what determines how unlikely a scenario has to be before it should be considered implausible, and therefore you don't worry about the fact that your management procedure breaks down if that was the reality. And this is where we hit the consistency problems. Because as you go around the world, and it may not be stated this way, but essentially there's a wide range of views on what constitutes plausible as far as assessments go. So let me take an example from the USA to show you the sort of problems we get into. And I'm not suggesting this is just a convenience. I'm not suggesting the same thing doesn't happen in other places as well. Particular case where at the end of the day, there were essentially two different scenarios about natural mortality. There were two scenarios about what value to use for the FMSY proxy to get the requisite recovery. There was a review panel on both issues. It could hardly distinguish between which to choose on the basis of the evidence provided. Yet the TAC that came out of these effectively four different options covered a range from 100% to 250%, so a wide difference. Now, what was chosen by the panel was the most conservative of those four options. And what happened after that is to allow for other uncertainties. There was a general rule in operation to multiply the answer you first got by 75% to allow for those. And the net result was the TAC was advised reduced by 83%. Now, I'm not trying to argue in this case that it shouldn't have been reduced. There very clearly was evidence that it needed to be reduced. The question is, but by how much? In fact, that 83%, I believe, eventually turned into 77%, but that's enormous, whatever way you look at it. And unsurprisingly, the industry as a result is in future crisis. Now, let's try to look at that in the context of characterizing what's going on in this sort of way of operating. When you do a single assessment, you'll get a TAC, but of course it's not a single number, it's actually a distribution. And really, there are always multiple competing models, even if you want to pretend they're not, and they're going to give different answers with different distributions. So what do? You select between them. Essentially, what you're doing is you're giving them different relative weights. And if you are just going to look at the best one, you're going to look at the one on the left there. But effectively what you have, if you want to think Bayesian, okay, I'm cheating a bit, but you've got a posterior on your distribution with the TAC. And if I make that a little bit larger, you can look at it there. Now, given that that really is the information you have on what the TAC should be, what should you choose? The mean happened to be about the same here. The best model result, 75% of the best model result. You've got to ask the question, are we overlayering uncertainty upon uncertainty in this way TACs are being adjusted? And is this really consistent with the precautionary principle? If I quote the Rio precautionary principle, there's a bit of that wording that people often forget, and that's in the last line there. The precautionary principle asks for action to be taken where there's serious threats, number one, and the actions taken has to be cost effective. That means there's a trade-off involved. It's not just precaution über alles. Okay, let me give you another example to illustrate the difference as you go around the world. What situation we had recently in South Africa with our West Coast rock lobster resource. It's a resource that was heavily depleted in the first half of last century. It's estimated to be at about 3% of its pristine abundance at the moment, and that's what the biomass trajectory looks like. Okay, you'd say pretty miserable. We've been managing it under management procedures for the last 15 years. The last revision, because management procedures are not set in stone for 20 years, you typically revise them about every 5 years or so, and the last revision, it was agreed to have a 35% recovery target. That's not 35% pristine over the next 10 years. It was actually only going up from 3 to 4% of pristine, because anything more than that would have decimated the industry in the meantime. And that was put in place in agreement with all stakeholders, but when push came to shove, the first year of operation, 7% TAC reduction proposed on the basis of the monitoring indices, and the government said no on the basis of so-called socioeconomics. That's all that was said. Now, this was the first time a management procedure output, because all our major fisheries on management procedures had been overturned this century. There were major protests on the front pages of local press from scientists and NGOs, and the Green Party instituted court action to actually close the fishery on the basis that it was below 20% of pristine level. Okay, what happened in the litigation? The scientists continued to support harvest, but under a management procedure as advocated. The minister suddenly announced commitment to the 35% recovery target in the first place, with the MP to be adjusted accordingly, so it was essentially brought into play, but only one year later. And the court rejected the application to close the fishery. Some of the comments in the judgment were that even though the resource had fluctuated between 2 and 4% of pristine, it had been doing so for about 50 years, so notwithstanding that low level, it appeared that sustainable utilization was possible, and that it would have been irresponsible to close the fishery given the high dislocations that that would have caused. So this takes me to what I'll call the Great North-South Divide, or if I'm uncharitable as someone else who should be nameless, at the moment suggested to me it's the North Atlantic rest of the world divide. Okay, ask the question, would North scientists and the Marine Stewardship Council have considered the MP target chosen here and the court judgment as defensible? Would we have got an MSc certification out of this? Haven't tried that yet. And importantly, as a sideline I'd mention here, one of the points at issue here is whether a regime shift has occurred. It's quite plausible that there has been a regime shift, but the question is, what's our objective basis to decide, yes, it has, or no, it hasn't? Okay, that's one example of the divide. Another example of the divide, not many large fish in the catch. Now, there are three explanations for that: overexploitation, domed selectivity, or increasing natural mortality at age. As the New Zealanders put it, either you hide them, number 2, or you kill them, number 3. And the sort of experience you get in debating this out in the North versus the South is in the North it's very difficult to get acceptability for either 2 or 3. In the South, we've seen this so often, we're quite happy with it, and as long as the data is not really consistent with explanation 1, we've got no difficulty with accepting 2 or 3. And of course, whichever of these 3 it is, has major implications for whatever you're going to decide your proxy MSY is if you want to use a spawner per recruit relationship. Okay, another great north-south divide. We'll all agree that the status of the resource, its biomass, is important. But if you go into the north, and I'm characterizing here, obviously, the focus tends to be on keeping fishing mortality less than FMSY. If you go to the south, you hardly hear fishing mortality mentioned. The focus is on getting a reasonable rate of biomass increase. And I've waited years to have an ICES audience to say this for. I had to pay Manuel a lot of money to get the opportunity. Let me ask the question, why are you guys so hung up about fishing mortality? What matters for a resource to ensure good future recruitment is higher biomass, not lower F per se, it's higher biomass. I could believe your fascination with F if you believed that CPUE was proportional to biomass, but the moment you come to assessments, you won't. I would maintain that your lay stakeholders much better understand biomass and a graph of a biomass projection than anything to do with F, where you struggle to give it units anyway. And I'd ask, so what if F gets bigger than FMSY for a period, if that gives you a greater catch and greater catch stability, provided you still make sure that biomass is increasing reasonably. Anyway, so having had my go at the northerners, and maybe you'll have some time to throw rotten tomatoes at me later, the essentials of this great north-south divide is there are great differences among scientists in acceptability criteria on this plausibility issue. And problems arise out of that lack of consistency, for instance, for things like MSc certification. Because I could quite easily choose you for any fishery. I guarantee I could choose you a group of 3 assessors who would say it would fail miserably on the MSc criteria, and another group of 3 assessors who would say it passes with flying colors. That's the situation we're in, and I would argue we desperately need to get our act together towards greater commonality on this question of acceptability of alternative hypotheses. Otherwise, we're rapidly going to lose credibility with our stakeholders to whom we give advice. Okay, let's go on to key problems facing scientists. First, a little bit about the research questions. MSY reference point estimation, which you need even with management procedures, if that's something to do with your target. Now, I pose the question in general, do we, sorry about the word have got lost there, do we have the data to estimate MSY and related reference points reliably? Are F-spawning spawners per recruit percentage, the F30%, F40%, are those proxies defensible? After all, they rely on yield per recruit. I'm not a great believer in yield per recruit because, first of all, you've got to tell me how defensible your M is, and then in any case, your M is age dependent, and that screws up the calculations too. So I'm not a great believer that that's really a defensible proxy for FMSY. And of course, there's that problem about regime shifts as well, and agreeing a objective method where we can say, yes, we're satisfied a regime shift has occurred, or no, we're not. Okay, what about other problems? Bundled a whole symposium, or whole two symposia into one slide here, ecosystem effects and climate change. And by ecosystem effects, I'm talking about the biological rather than the environmental effects here. I'd say it's unlikely in the short to medium term we're going to have models with accurate prediction capabilities. There are going to be a range of models that can do different things, and I think that's going to have to be dealt with using feedback control and management procedures. In other words, we react to changes by continuing to monitor the resource and reacting to the data as it comes about. And essentially, what I'm arguing for here is what we heard in a very good talk, I thought, yesterday by Gavin Fay in the session E. The sort of work he's doing is exactly the sort of way I think we've got to go on both these topics. But enough of that. As I say, I'm not doing justice to it because of time concerns. Let me talk about the appropriate role for scientists. And there, let me take you back 5 years to the 2008 watershed, unfortunate year in Iceland. But I'm not actually talking about the world financial crisis in 2008. I'm talking about what happened in fisheries, which was a quiet revolution. And I don't know many government fisheries ministers are actually aware of this. But they actually surrendered their national authority on fisheries policy in a coup d'etat by the buyers of North European supermarkets. Now, what am I talking about there? Remember, 2008 is the year when NGOs persuaded the buyers in those supermarkets not to accept fish without MSC certification. And what was the result? An explosion. The MSC had been pretty much in the doldrums up to that time. There was suddenly an explosion in applications for MSC certification when fisheries realized that the buyers were getting serious. Now, what have been the implications of that for the MSC? There's a large investment in effort in an MSC certification. Roughly, it's 30 person days per stock per year when you take both their 5-yearly assessments and their annual audits into account. And they're dealing with approaching 250, it's actually fisheries rather than stocks here because they certify, in some cases, different fisheries on the same stock. Of those, or what that amounts to, is about somewhere between 30 to 40 person years of expert input, including about 8 to 10 person years of high-level stock assessment expertise. Now, the MSC is already aware that this is becoming overburdensome. They aim to halve these figures. Nevertheless, at the moment, they're only dealing with 10% of the world fisheries. And my worry, as I've said a moment ago, is the consistency they're getting out of this process. They're also worried about that. They are planning a peer review college, which at minimum is going to put together a lot of scientists who have experience with their reviews, and they'll encourage certifying agencies to use that pool in choosing the people they get to do their certification. So that may help with consistency, though ideally what I'd like to see is a system like you use in ICES, which used to be called ACFM, now ACOM I understand, which essentially does a review with a particular intent of ensuring consistency across species. And I know the MSC, when I debate this with them, say they would like to go that way, but there are practical problems. But until that problem is solved, I think this consistency problem is going to be with us. But then let's go back to the scientists themselves. What about the implications of this? Eco-labeling has imposed a considerable further demand on what is an already stretched resource of assessment scientists, which is a limited resource worldwide. And it's not only those people the MSc is absorbing. Remember, it's an additional load on the assessment scientists who are responsible for those stocks in the first place. And this is but one of an example of an explosion of assessment reviews. And quite honestly, I think we've got to think seriously about a more effective use of what is a limited resource. I think we need fewer but more intensive reviews, because I think a lot of the reviews are superficial and not really that valuable. I'd also say we need more focused assessment reports, and to be honest, I don't think it is something to be proud of, and no names, no pactoral, no countries mentioned here, when I hear of assessment reports that run to hundreds of pages. I ask the question, is that the best use of a limited resource? Aren't you into diminishing returns territory? And I don't think, to be more controversial still, that the answer is training people in doing what I call black box assessments. Assessments should be, they're difficult and they should be carried out by professionals. If you want to train people in black boxes, train them in implementing simple MPs and leave the development of those MPs as well to the experts. Okay, the appropriate role for scientists continued. What about the nature of the advice we give? Well, there's wide confusion internationally on that. Let me tell you some secret stories from RFMOs, some quotes there. Once from, again, the organization shall be nameless. But one chair of a scientific committee who had to report to the commission, there was the argument that we must provide in the scientific committee, that we must provide options from which the commission should choose, and he said, but if you do that, they'll just say to me, but which of the options do the scientists recommend? Another case, we had the case of one delegate to the scientific committee who was absolutely adamant. My commissioner has told me that nothing more or less than one single TAC recommendation from the scientific committee will be acceptable. And that was rather difficult for other delegations who had instructions from their commissioners to do exactly the reverse, not to say anything specific at all, but to give a number of options and their implications. Now, quite honestly, that last approach is, I think, what the appropriate role is. But let's be honest again, scientists play games. And maybe because they justifiably, well, I didn't say that, there were plenty of question marks after the word, please note, mistrust whether managers understand all the issues. And we all know the nature of that game. When you give a set of options, you make sure the one you want is the one in the middle. So people who don't really understand what they're all about are happy with going for the one in the middle, because then they don't have to explain themselves. So anyway, you can wake up again and some more work for you. Question. Here are 5 groups that contribute to the fisheries management process. They're in alphabetical order here. Put them in order of which you think make the best contributions. Okay? Now, if you ask the public, I'd hazard that this is the order they'd come up with. You may disagree with me, but at any rate, look at it that way. Now, let's just consider a few aspects of the actors in that game. Big industry. The one thing about big industry is they can financially afford to look at a longer time horizon, because they've generally got financial reserves and effectively they've got a lower discount rate. What about the managers? I think the big problem we have with fisheries managers is they're not in the game long enough. They move on very quickly, and so they don't really have the time to thoroughly master the concepts. What about NGOs? Not all NGOs, but a large number of NGOs have a problem which is put upon them by their funding model. Essentially, they require regularly to have new issues to go to the public to raise funds about. So essentially, they end up continually raising the bar. And what about small industry? Well, they've got the very problem that large industry don't have. They can't afford cutbacks because for them, they have no reserves, and the cutback is the same as suicide. So much for them. What about the scientists? Now, I've really got to be careful about the rotten tomatoes in the audience. Well, current US law, interestingly, has moved much further than in other countries and essentially declares scientists to be the primary authority. Essentially, it says that TACs may not be set any higher than the scientific recommendation. And this is a great opportunity for scientists, but I ask the question, are we up to the task? I've listened to some, admittedly not that much, discussion in those committees, and quite honestly, in some cases, not in all, I haven't been very impressed by, I could have said the knowledge, the lack of knowledge, and the irresponsibility that I think shown by some of the comments. And I ask you as scientists to think very carefully, scientists who've sat in those committees, and say, if you were an observer, you had your life savings invested in a fishing company, and you were listening to the sort of comments you hear emanate from some of the people around the table discussing what the TAC should be, and what is essentially your future, whether you're going to go bankrupt or not, would you be very happy about the situation? Okay, no rotten tomatoes yet. Okay, you may all be asking yourselves, after all that, what's my order in those 5 groups? Who do I think is best? Well, you can ask me later, and don't bother because I'll plead the 5th. Okay, to finish up, looking ahead, what about objectives? Now, I want to be provocative, so drop MSY-related targets unless, in zucchini speak, we can estimate them reliably. In most cases, I don't think we can. I would suggest, until such time as we get data to estimate them reliably, not to use the proxies, which I think are very dubiously defensible anyway, what we should do is manage in terms of observable set targets in terms of past CPUE levels or survey abundance levels until we can get that information. And how do you select between different ways of getting to those targets? Well, the primary trade-off is how much might you have to lose in the short term to employment and catch versus how fast you want to get to that target. And that's a trade-off. And I think the trade-off should be made in the particular circumstances of the case. That gives problems when you're a single country with a large number of fisheries. You want to treat it equivalently, but I think it's a problem that's got to be faced. I'd also argue to drop F-based targets, and that they should be replaced by a focus instead on biomass rates of increase and low levels of TAC variability. Looking ahead as far as the future of assessments is concerned, I don't think the single best assessment is usually defensible, because there's never a single model which is better than everything else. And by model, I mean both at the level of selection of parameters, for instance, the natural mortality value, but also at a structural level. You make structural assumptions in any model, and there are different models with different structural assumptions, and they have a claim to plausibility as well. And what you've got to look at is a range of models consistent with the available data. I'm not advocating necessarily with those multiple models to move to model averaging, but what I am advocating is that we have to move to risk analysis. In other words, you have a range of models, you have a range of possible management actions, and you look at the complete matrix, and you select the management option which you think gives you the best and most defensible trade-off. Okay, what about management procedures? The problem there, which I haven't mentioned so far, is they take longer, the analysis takes longer than the normal assessment process. And I'm afraid, much as I like them, that problem, together with lack of the technical expertise, will limit the level of large-scale introduction of management procedures in fisheries. But nevertheless, I think there are 2 points. First of all, I think it's worth considering further the sort of simple approaches I showed earlier with some of those North Atlantic stocks. And secondly, in the data poor area, which is really the majority of fish stocks, if you think about it, that's where these approaches have the greatest potential to provide us generic approaches which we can say are robust to uncertainties, and that, I think, is an urgent priority. And finally, what about the scientists themselves? Where do they need to improve? Well, consistency in treatment of uncertainties. We're all over the place there, and we need to get it together. Responsibility, if we're going to be given the responsibility of giving advice at the level, for instance, that has happened in the US of A, we need a greater breadth of consideration in developing that advice. That's what I'm looking at by responsibility. I think I've made my points clear earlier. And finally, and by no means leastly, communication with stakeholders, management, industry, NGOs, etc. The problem is our training. Our training is quite correctly emphasized. We must be thorough. We must defend our assumptions. We must explain and justify our analyses, the methodology we used. Now, when you think of our presentation to stakeholders, the problem is what's necessary there is exactly the reverse of what our training has taught us, and we need to learn to be able to do it both ways. We need to be able to focus when we're doing that stakeholder presentation. So with that, thanks very much, and thanks to those who assisted me, but I bear full responsibility for the comments I've made. Thank you.
Thank you very much, Doug. Yes, we expect inspirational and controversial speakers, and you did both. And don't worry about the rotten tomatoes. There's an extra machine at the entrance of the hall that beeps if you carry tomatoes. We needed to implement that in ICES. I'm sure that there are lots of questions in the audience, and we have only a couple of minutes, but if there are a couple of quick questions and quick answers, maybe we can get them in.
Thanks, Doug. Lots of comments, really, but one quick one. You accused the MSc of draining the world of stock assessment expertise, but surely you also provided the solution earlier on. So if we all move to empirical management procedures, we don't need to tie up the stock assessment scientists doing annual assessments. Do you wish to comment on that?
Well, I'd like to see us going that way, but I think it's going to take time.
That's a quick answer. Back there.
I have a question or a comment about the example about soul. And my comment is that I think there is two things mixed up. Your argument is that it's the assessment that's actually kind of causing the differences that you see in the, say, in the targets that you chose. But what is going on there is also that the policy objective for this stock was a relatively high F, which kind of implicitly was the explicit kind of wish to also keep employment in the fishery high. And that is exactly what is not in your targets. You did not kind of show kind of the level of employment in this fishery. Can you comment on that?
Yes. What we're doing is a simplified exercise here. You're absolutely right. These fisheries were not managed on the basis of a common complex assessment method which was routinely applied throughout the 20 years. But we wanted to start somewhere with these analyses, and we wanted to get a general point across. Yes, there were variances in these other factors. The same thing in some of the other stocks we've done this for. But the point of the exercise was not to claim that the comparison was exact. The point was just at a simple qualitative level to get across the fact that you can do this more simply, and in particular, you can do it with much less variability in catches than you typically get with annual assessments. This is not the only case where we've done this. A more thorough comparison was done 20 years ago by Andre Punt for South African hake case, and he contrasted production models which aren't as simple as empirical procedures, but with age-structured assessments, and essentially showed that all the age structure gave you was more variability in TACs without any gain in terms of reducing resource risk. So yes, you're absolutely right. The situation is more complex than we showed there, but nevertheless, we're trying to point to a broad general conclusion rather than trying to defend the nuances of the details of those cases.
Thank you. We'll have the last question. Ken?
Thank you. Kenneth Patterson, European Commission. Well, thanks for a great presentation. I just want to try and respond on one point, which is the north-south divide on a target of increase in biomass or a target of fishing mortality. because we've lived through the experience of the North Sea Cod Recovery Plan, which we kicked off with the principles that you described, with a target increase of a 30% biomass increase year on year with a catch constraint. And that worked for a couple of years, but it fell apart. And it fell apart for two reasons. Firstly, that if you have a depleted resource, which depends on incoming recruitment, trying to aim for an annual increase results in a very high variability in fishing mortality, according to incoming recruitments, which make up a large part of the biomass. And trying to manage that high variability, even with a TAC constraint, caused a lot of problems. And the second one was the credibility of the biomass rebuilding target, that we were criticized for aiming for a biomass target which was highly uncertain and not well justified in science, and particularly whether the biomass target was dependent on the strong year classes of the mid-60s and was an unrealistically productive situation. So for those two reasons, we've actually amended that cod plan and gone back from a biomass target to a fishing mortality target on demand from the industry, that we have a more stable fishing mortality, and rather than aim for a biomass target which is scientifically not well supported, we simply aim for a good low fishing mortality rate and let the biomass take care of itself. This is how we've ended up on that process. And from that experience, we've really maintained our preference for fishing mortality targets in Northeast Atlantic.
Thank you for that comment, and it's good, I think, to open up the debate on this. Clearly, I can only give a simple answer at this stage, and I hope we can continue that debate in some form, someplace, sometime in the future. But I think there are essentially 3 points to make in return. Number one, even though you're aiming for constant for fishing mortality, you've got to translate that into a TAC if you're not measuring by effort, and there are uncertainties in that. The second point is, remember when I said in terms of targets, I didn't say in terms of a biomass target, I said in terms of observables, that is particular values of CPE or survey abundances. And the third point is I didn't say to keep a constant rate of a biomass increase. You are going to have to deal with the fluctuations in recruitment. But the key point about the management procedures is the trade-off element. That I didn't say you could keep TACs constant, but what you have the trade-off between varying TACs and achievement of your targets. And the debates we have back home, when we have with industry about management procedures, are almost all in terms of what restrictions are we able to put on the extent to which TACs vary from one year to the next. That's a key component, and I think if you do that in a management procedure context, you in fact deal with most of the problems you've raised. But thanks for the question. That is the fundamental issue.
Great, thank you very much. I'd just like to end the proceedings, because it's eating into coffee time, to thank Doug again for a very inspirational and controversial presentation. There'll be time for discussions, 3 days of meetings still, and I'm pretty sure that some of the things that you mentioned will be discussed in some of the sessions that follow. Thanks very much, Doug.